This is just a little organizational technique to think about all the functions and derivatives that we've done in this chapter. So you can make this chart. It's meant for you guys to fill in. I'm simply giving you an idea that we have exponential, logarithmic. You can fill in those rules, as well as the inverse rules, the implicit method, and then today's lesson is going to be on what's called logarithmic differentiation. It's a special function, x to the x. Now, when you guys are ready, we will look more closely at what's known as a logarithmic differentiation. Okay, and it is yet again another strategy for a derivative, but it fits into a special category. Again, the category is when x is in the base and x is in the exponent. So how do we do the derivative? Okay, we've come to the right place. Let me give you some more details here. We almost have to back up a second, because x to the x, it's a special kind of function, and it requires, because the variable is in the base and the exponent. So we want to just kind of make that clear. X is in the base, x is in the exponent, and then it requires a special type of differentiation. Differentiation is just the I guess that would be like is that a noun or verb? I don't know. That's why I'm teaching math. But differentiation is just the process of finding a derivative. I guess it would be a noun. But I'm going to show you some steps. We haven't done too many steps, but this one, you do this all the time. And so you're going to find yourself taking the log of both sides. I'll show you why, but I just want to tell you, you're going to take the log of both sides, and that's special. And then you're going to use implicit differentiation. And so that's something that we grab from a couple lessons ago. And then there's always this substitution step. Logarithmic differentiation. Now, I will be honest with you, sometimes this one starts to separate kids a little bit. I think that every one of you has the ability to do this, but we start to get to the point where it's like, wow, another rule. And then the rule is more of a process. So trying to put all this together, it takes some focus. It takes some sort of determination. And like I said, I believe everybody can do this. You can't use an old rule here. Okay? On a test, I would rather you say, Ms. Naylor, I know that this requires a special method. I know it's not going to use an old rule, but I don't understand the method. Now, of course, I hope that that's not true, but I'd rather you tell me the truth than say something like this. Bring x down and subtract from x, I don't know, x minus 1. It just doesn't look right, because this is not a power function. A power function is when the exponent is a number, and then we can subtract from the number. So that doesn't make sense. It also doesn't make sense for someone to try to say that it's e to the x, and then they just kind of write down the same thing, because it's not e to the x, it's x to the x. So we need something new. We need to take the log of both sides. We need to use implicit, and then there's even a substitution. All right, so Step number 1, focus with me here because you can do this. What you have to realize is that what I've done right now is not calculus. It's some more advanced algebra, but you guys have taken the log of both sides before, and if you haven't, just notice what happens. The exponent comes tumbling down. I even made a little joke about it at the beginning of the year because it's kind of like you slapped both sides with a log. When you slap both sides with a log, the exponent comes tumbling down. Now, the truth is that exponent was making this problem tricky, but it's not an exponent anymore. It's now just a product. It's a product. And actually, kind of just like that, we turned this problem into a product rule. We also turned it into an implicit because y is no longer solved. It's implicit. So all that means that I have to do the derivative of both sides. Let's do the derivative of this side, the ln of y. Okay, I'm not going to call on anybody, but this is from Friday's lesson. The derivative of ln is that sort of amazing reciprocal, 1 over. That's the derivative of an ln, 1 over y. Are you feeling like we're not done yet? You have to do the derivative of the inside. You have to do the derivative of y. That's the implicit part. That's implicit when you get that dy dx. Okay, product rule. Already mentioned it, but it doesn't hurt to say it again. We're going to do the derivative of two products. Well, two products. So first derivative of, the derivative of ln. We just talked about that Friday. That's 1 over x. Okay, so that's first derivative of second plus second derivative of the first. It's just going to be ln of x. How you guys feeling so far? Okay, yeah, this is kind of how calculus works. We pull a little trick, like take the log of both sides, and then everything else is what we've already done. But we have to see it through. I hope you see that this is equal to 1. We could change that whenever you're ready. And, this 1 over y, we need to multiply it over to the other side. We're going to multiply y to the other side. We're trying to solve this thing for dy dx. So I don't want that y over there. All right, so we get 1 ln of x, that quantity times y. 1 plus the ln of x times y. Now, you've heard me say this before. This is also part of maturing through math. This y is a little out of place, okay, because my original problem was completely in terms of x, which means my derivative should be completely in terms of x. It's a really simple substitution, though. We're just going to write down what y equals. That was the original problem. It equals x to the x. So again, we're going to substitute x to the x for that y. Now we have a better answer, okay, because it's in terms of x. Now, x to the x is sort of your most basic special function, where x is in the base and x in the exponent. Next time you do x to the x, it's going to be the same derivative. You could almost argue that that's a rule. I don't want you to memorize it. I want you to understand the process so that if I give you something else that is in the category of x to the x, so you sort of catch my drift here. It's not x to the x, but it's in that category where we have x in the base and we have x in the exponent. That means you have to do logarithmic differentiation. You can try it. That's what I kind of expect that you're going to do here. I'll be a step behind. Okay, so be willing to try. It's going to be the same thing. The reason that you're taking the log of both sides is to make that x come tumbling down. Feel free to take a look so that your next step goes correctly. It's always going to create a product rule. It's always going to create a product rule. It's always going to create the derivative of both sides. So the derivative of an ln from Friday's lesson is 1 over. This is an interesting derivative. How did you do? Did you try the product rule? Did you do first times the derivative of the second? The derivative of the second is going to be another 1 over. Okay, so it's 1 over the inside left alone. Now that would be like the derivative of the outside with the inside left alone. But I need to finish by doing the derivative of the inside. Now the derivative of cosine is negative sine. So that was part of finishing the derivative of that ln. Plus you have to finish the product rule, which is just the ln of cosine times 1. This should be grabbing your attention. Don't ignore it. This kind of yellow polygon here should catch your attention. That is sine over cosine. Yes, that's tangent. You should be changing that to tangent. Plus there's an opposite sign. So that's kind of slick. We can change that. Students seem to catch on that you're always going to multiply the y over to the other side. I don't care if you show it. I just want you to do it. So you're always going to multiply y over to the other side. And if you don't want to write down extra steps, you're always going to substitute that y. All right, so we get the opposite of x tangent x plus the ln of cosine times the y substituted back to be cosine of x to the x. The problem doesn't necessarily have a lot of cute simplifying. It just has to follow this process. When you guys finally do take the test, it's going to be after you return from break. These problems are going to be all mixed up. You have to use the right method when you encounter something like x to the x. Now, I've got one more here. Yeah, let's do it now. It's a neat problem, though, because it can be done 2 different ways. And I guess what would be maybe smart here is to let you, by instinct, choose one of the ways, and then I can show you, or maybe someone else can show you the other way. Just to be clear, you still have to start the problem with logarithmic differentiation. So you have x to the ln of x. You definitely are going to have to take the ln of both sides. Now, a lot of you, which was totally right, you treated this as a product, and you can kind of proceed with the product rule, which is first derivative of second. Now, the derivative of ln is 1 over x. Maybe to clean that up, you can just write it as ln x over x, plus the second derivative of the first. Well, it ends up being the same thing because the derivative of the first is 1 over x. So I can just put that underneath. But there's another way, right, Colton? You did something different right here. ln of x times ln of x. So what's the derivative of ln squared? How did that go for you? The derivative of the inside, right? Which would be the derivative of ln, which is 1 over x. Okay, now what I hope everybody's realizing is that we can put an equal sign right here and end up with the same thing. It's kind of cool. We can end up with the same thing, which is that we have 2 ln of x's, both divided by x. Okay, so the product rule. Yeah, I'm glad you're starting to see it. That shows a lot of growth. Sometimes we can actually turn something into a chain rule, and of course, we get the same answer. Make sure that you multiply y over to the other side. Don't forget that step. And as some of you will do, you're just going to put whatever y equals, you're just going to put that over here as x ln to the x. So we have 2 ln of x over x times x to the ln of x. Crazy stuff. But remember that this is the derivative. It is a formula. It gives you the slope. And it actually gives you the slope of this special equation. These special equations are equations where x is in the base and x is in the exponent. All right, now that officially ends the section, and it also officially ends the chapter. But we're really at a crucial point where you have a lot of processing to do. I mean, you got to put this stuff together, and you do that by working on the assignment. You also do that by hopefully starting to organize your thinking. And again, this little simple chart is a great way to kind of think about the rules. It might be something that you want to fill out in more detail. Sometimes students want to show it to me, am I missing something? But if you fill out the chart, now, then you can kind of be looking at it when you're working on your assignment, when you're reviewing for the test. And that's something that we'll do tomorrow, actually have kind of a fun, it's actually a review activity, but it's also just kind of a fun activity that we'll do. I hope that you're here, but students that have kind of done some organizing tend to have a little bit more fun with that also tomorrow. When you guys come back from lunch, I don't have anything else. I'm going to encourage you to work on your assignment. So that might be this assignment, or it might be finishing up the inverse so that you can get started on this. But I'm going to just give you the other half of the period to begin. Okay, and notice that it's due on Wednesday. We're talking about Wednesday, December 2nd.